Good evening, fellas.
What's going on, Sonia?
There. Guys, I have to run out on the road and come back, okay?
All right. Hi guys, how are you? Hello guys, anybody hearing me? Hello?
Well done, sir.
I'm good, thanks. You finish your question?
Yes, sir.
All right. Chevy, Simon, where you stay?
Oh, sir, I better finish as it. So.
Finish now, Chevy?
Sir, I don't know what I'm going, sir.
Oh,
Yeah, the doors out.
God, Jesus.
Doors out, sir. Now go on detail now, sir. Now go on detail now, sir.
Trust me. When nobody says that I'm tired, there's nothing you can do about it. Mm. Oh, come on. Mm. Oh, find my, find my connector. Oh, I don't know where it is. Let me see if this will connect with devices, because if not, problems. Well, it's connected. Let me see if it will work. No. Oh, thank you, Lord, it works. I don't know where the connector is. I'm happy that it works. All right. Let us. Sham, you hear me, Papa?
Yes, sir, man. You're
All right, cool. So f of xy. Chevy, wake up.
Yeah, man, sir. Yeah, man.
All right, cool. 2x squared plus 8y. Now, and the constraint is going to be x plus 2y is equals to 7. We're going to shut up this like a boss now. So remember, we are doing our differentiation using our x's or partials. So this is going to become 2x minus 2 is equals to alpha. Agree with that?
Agree.
Good.
That's lambda, sir.
Yeah. I said that to see if you're paying attention, Shamari. Leave me alone. Lambda. Thanks, Papa. All right. And then, similarly, I'm going to have 4 2's 8. 8y plus 8 is equals to 2 lambda. Everybody agree with that?
Agree.
Good. So this is going to be 2x is equals to lambda plus 2. And x, when I divide both sides by 2, I'm going to have x is equals to lambda plus 2 over 2. Please do not cancel this 2 into this 2 and call it lambda plus 1. That would be incorrect. Very wrong. I'm not calling any names, but I have an idea what is happening. Right? Yeah.
Go on, sir.
No, can't do that. Can't be beside a positive sign or a negative sign. It has to be a multiplication sign only. And then I'm going to have 8y is equals to 2 lambda minus 8. Divide both sides by 8, similar fate. So y is going to be equals to 2 lambda minus 8 over 8. In this case, I can factor out a 2 to say 2 times lambda minus 4 over 8. And then this 2 into that was 1 and this into that was 4. So y then is going to be equal. See, I can only cancel beside a multiplication sign. This 2 is multiplied by x by lambda minus 4. So now we're going to have lambda minus 4 over 4. So I'm a value of my x and my y. I get those, then I'm going to substitute into my constraint. X is lambda plus 2 over 2 plus 2 times lambda minus 4 over 2, and all of that is equal to 7. Am I on the right track so far?
Yes, sir.
All right. No.
2, 7.
Supposed to be 4. I'm doing a question one step ahead of myself. Oh, no, sorry, it's not supposed to be lambda minus 4 over 4.
Hold on, sir. Lambda minus 4 over 4.
Don't.
Yes, sir.
I had what I did, what I wrote right here was I wrote a 2 here because I was doing the question in my head while I was doing it. But I was right. So it's supposed to be lambda minus 4 over 4.
Yeah, for y, for y.
For y, yeah. And then no,
Sir.
I said, go ahead, Papa.
And I step before you get the lambda minus 4 over 4. I'm gonna see how it changed from 2 lambda minus 8 to lambda minus 4. Or why how come they gone from 8 to 4?
I factorize in a 2. So if I do this, I'm going to say 2 times lambda gives me back the 2 lambda, and 2 times negative 4 gives back the negative 8.
Oh.
So I'm factorizing because I always try to work with the smaller numbers or terms. And then now because it's over 8, know that I can, 2 is a factor in the numerator. It is also a factor in the denominator. So that's why I did it. If I couldn't factor out something in the denominator, I wouldn't have done anything to it. So 2 into 8 goes 4. But if you use it as 2 lambda minus 8 over 8, you will get the same answer for lambda. But it's just that your value is going to be bigger than mine. So don't change anything that you have just yet. All right? So my equation now will be lambda plus 2 over 2 plus lambda minus 4 over 2 equals 7. What I'm going to do is to find the LCM, which is 2. 22 goes one time, and 1 times lambda plus 2 is lambda plus 2. Plus 22 goes one time, and 1 times lambda minus 4 is lambda minus 4. And that is equals to 7. Lambda plus lambda is 2 lambda. And 2 minus 4 is minus 2 over 2 is equals to 7. I can factor out a 2 from the numerator to be 2 lambda minus 1 over 2 is equals to 7. Those two cancel. So what I'm going to have is lambda minus 1 is equals to 7. So therefore, lambda is equals to 7 plus 1. Lambda is equals to 8. Did you get lambda to be equals to 8, Shamari?
Yes, sir.
See? Saying about the same thing. The difference between my calculation and yours is that my calculation looks easier than yours. Talk truth.
Truth, sir.
So because I just factorize and just use some smaller terms. So I got the value of lambda. The question
Sure.
getting go ahead, Papa.
Well, could have cancel out the 4 up top there, so like x equal lambda plus 2 over 2. Why could we just get to that 2 up there? So
Right, sir?
yeah.
Because the one who just say, me married to that 2, you know. This is me, and I have 2 girlfriends. So you can't just come to with the 2 girlfriends and let me alone. Can't work. So that plus 2 is, if you do it like that, if you do it like what you asked me, it means then that I'll have this lambda over 2 plus 1. That's what it means, because lambda plus 2 over 2 is saying lambda over 2 plus 2 over 2. And
Yeah.
then that gives me this.
Yeah.
But I wouldn't want to work with 2 different fractions. I just want to work with 1 fraction. That's why I have to find the LCM right here. So weird. Right here, so. That's why I had to find the LCM there. Because it makes life so much easier for me. Because what I want to end up with now is 2 fractions separated by an equal sign. But I canceled out the 2 in the numerator and the denominator, so that one worked out very nicely. And I got lambda just to be equals to 8. Very nice. So now that I know that lambda is equals to 8, all I need to do is to substitute it back now into my x value in relation to lambda and my y value in relation to lambda. X plus 2 over 2. So recall, x is equals to lambda plus 2 over 2, and y is equals to lambda minus 4 over 4. So with lambda equals 8, x is going to be, and you notice what is happening here? I'm not finding any square root to give a plus or minus 8, as opposed to the other questions that we're doing. True or false?
True, sir.
Because the constraint didn't contain any square terms. So this is the first time we're doing a question where the constraint didn't have a square term in it. True or false? You disagree with me?
Feel like we can find one without
Yes,
a
sir.
square there.
Yeah, I think you give one without a square answer.
I gave you one without a square, and lambda was just,
Yeah, we're gonna get one set of answer.
I saw it go. Well, I can't even recall, but fair enough. But I'm happy though that we're doing this one in particular, because I don't want you to always believe that it's going to be squared. Them can't give you one of the terms being squared, both terms being squared, or none of them being squared, as in this case. All right? So let us continue. So it makes it easier this way. So lambda is 8, so it's going to be 8 plus 2 over 2. 8 plus 2 is 10 over 2. So x is equals to 5. Y is equals to 8 minus 4 over 4. Y, 8 minus 4 is 4 divided by 4. Y is equals to 1. So x equal 5 when y equal 1. You got that, Shamari?
Yes, sir.
x plus 2y equals 7. X equals 5, y equals 1.
No, the function is supposed to deal with now, sir.
Yeah, that's the function. When we write a while ago.
I constraint, right?
Ah, thank you, my son. Thank you, sir. Sir, you're right. The understanding x squared plus 4y squared. All right. Read out the function for me, please. Yeah, because read out the function for me, please. F of xy is equal to
X square plus 4y square minus
Mhm.
x plus 8y.
That's it.
Yes, sir.
Yes,
All
sir.
right. Good. Thanks, Papa. This what I've done. All right, that's x of 5, comma 1. Is equals to 5 squared plus 4 times 1 squared minus 2 times 5 plus 8 times 1. 5 fives is 25 plus 1 squared is 1 times 4 is 4. 2 times 5 is 10 plus 8. 25 minus 4 is 21. 21 minus that is 11. 11 plus 8 is 19. I get 19. We get.
Sir, you just said 25 minus 4, but a plus 4, sir.
Sure. What is wrong with me tonight? 25 plus 4 is 29. 29 minus 10 is 19. 19 plus 8 is 27. Am I correct right here? No?
Yes, sir, that me get.
Good job. Big up yourself.
Me did confuse, sir, because that would I mean is a maximum and the question say minimum to find the minimum.
What the question say? Hmm. Hmm. Well, it means that that is the minimum value.
That me did I think to, sir.
Yeah, man. It would have, because on the one, you see, it says value or not values.
Yes, sir.
And because it only gave us one, it means that is whichever value we get is going to be the minimum. But you sound like you're a little more comfortable with the topic, though, right? True or false?
True,
Sure, man.
sir.
Yeah, man. Chevy, what you state?
Sir, I just
The division of the x-ray divided to two into each other.
yeah, man, that threw me off, man, sir. I'm not to like get the thing carried so far up, you know. I think
Yeah, because when you get it wrong up way up top, say it's throughout the whole question, and then when they can't, and I mean, if you throw out the question, chances that you're not going to get nice answers like we would have gotten here.
definitely.
Yeah, so this is going to be the minimum value. All right. I did promise you that, for the last couple of classes, we're going to do the stuff. I wanted to look at some differential equations today, but I recognize that the Monday decided to them now come a class. Simon keeps dropping out. So what I'm going to do is we look at one constraint. For the most part, you have it. Let me just make up some double integration. questions here. Hmm. Let me not give you. I have enough time. Can do a few. Let me give you two indefinite or an indefinite one. So let me ask the question now. Whichever way works for me. Do you want to try that question first, or do you want me to work it with you?
This is a question.
Double integration. Whichever way works for me, you know. You want to try to answer how far you can get to the question? Whenever you stop, you just tell me so I can just start. You want to do that?
Yes, sir. Can contribute first.
All right, just get a one try. But that means that function that means that it can work with it then. Because they're using the C port and C port to C port. That means if I use the regular charger, if I use a regular charger, it's supposed to work. If the C port to C port work, you can use a regular charger connected to. All right, let me try it. It should work. If I use a regular charger and they oh, it don't work. But there's power going too. So why not working and there's power? There's power going to it, so why not working? Is it not strong enough or okay, not strong enough period? Let me have a look sure of this piece then because let me see how this one works. All right. How is it?
Yeah, I'm get the answer, but I think it's correct.
All right, no worry, not touch it yet. Shamari, how is it? Shamari, you gonna see it, man?
What one time, just come back.
Oh, I was asking you to finish.
Yes, sir.
All right. What you got for your answer?
I got x square y square upon 2 plus 2x square minus y square upon 2 plus cx.
What you get, Shaboy? Chevy?
No, me answer, sir. This not good, sir.
Tell me what you get, man. Don't worry about it. Tell me what you get.
So I'm get 2 plus CX plus C.
2 plus CX plus C.
Yeah.
All right. Um, this for you looks good. I don't do the question yet. Something is missing here um for Shamari, but I will doctor it now. We're gonna look at it now. And we're gonna look at it now. Give me 1 second. Not sure. All right, so we'll pause it and give me 2 minutes. Aston, I don't know if you got a chance to do it, you just came in, so what shall I go on? All right, so let me attempt it. Which one am I integrating with respect to first?
Right.
Very good. Very good. So remember, work inside out. So I'm integrating with respect to y. Putting by the auto integration sign, and I'm integrating with respect to y. So I'm adding 1 to the power divided by the new power. That one is done. That one is done. Let us double check to see if we are correct. If I were to differentiate this with respect to y, this 2 multiplies by this 2 to give me 4, but 4 divided by 2 gives me this 2. This x is this x, and we're reducing this by 1, so it works out to be this. True or false?
True,
Come
sir.
again? Please.
If I differentiate this with respect to y, I'm going to get 2x times 2y over 2. I'm finding the partial derivative of 2x, y squared with respect to y over 2. So my 2x over 2 is a constant. And then I'm differentiating y squared. I'm going to do it 2 ways, because I just understand another way. When I differentiate y squared, we get 2y. This 2 cancels with this 2. X times 2 is 2, x times y is 2xy, which is equal to what we started off with, 2xy. Or we have 2xy squared over 2. The 2's cancel out first. When I differentiate xy squared with respect to y, I'm going to get 2xy. So whichever way I do it, I get about the same thing. So I know that this is my differential. And it's finished right there. The reason I spend time on that is that I want to show you something else here. I'm going to show you something else here. Now I'm differentiating 4x with respect to y. What do I get? Is that a constant? 0? Call it, what I do? I just call it a day. What do I do with that? 4x. I'm different.
Come on. Think. I put C.
Wouldn't it become a constant?
4xy. Differentiate 4xy with respect to y until we get.
But then a 4x what? Well, so you have 4x minus y.
Me see it, sir. Me see it.
4x, right?
When I'm differentiating, when I'm integrating Astonel, the multivariable function, when I'm integrating 4x.
Oh, yeah, multivariable. All right, sir.
Right, it's multivariable. So you have to think differently with multivariable than single variable, you know. So multivariable, but I forgot to say, yo, I forgot each of a y. And let me show you why. Sideward. Four x y to the 0. Is that the same thing as 4x?
Yep.
Because anything raised to the power 0 is 1. So 4xy to the 0 is simply 4x. So when I'm integrating this now, I'm adding 1 to the power, so it's going to be 0 plus 1 divided by 1. So that now becomes 4xy over 1, which is the same thing as 4xy. So we have to bear that in mind. Remember, every time you do a multivariable integration, just quickly differentiate and see if you get the term before. If when you differentiate and don't get the term before, you know there's something wrong. That's all I ask of you. All right, let's go. I'm now differentiating rubbish. I'm now integrating minus y with respect to y. What do I get?
You say integrate and differentiate, right?
Integrating, man, integrating. I make a mistake while ago. Integrating minus y with respect to y. What I get?
Y over 2.
Very good. Minus y over y squared over 2.
Yeah, minus y squared over 2.
And I put back my dx. Do I put my dx right there, so? Finish now?
Going to do the x.
Hmm?
But finish with y, sir. Need to
We'll
do
finish
it.
with y now? Shamari, are we finished with y?
No, so you go put a constant.
Very good.
Yeah.
You get tricked a while ago, Shaboy. I have to put my constant. That's why I was asking the question, and hopefully it would have triggered something. So when I ask the question, I have a question okay, done. No, man. You have to put a constant of integration. It's indefinite. No, it's finished. I can't tell for true. No, it's finished. I can't trick you again because if I know the trick already.
It's in.
No, it's finished. No, we're going to integrate now with respect to x. We're now integrating with respect to x. Are you okay, Aston Hills?
Yes, sir.
Is Simon back? Simon, what happened to your system tonight?
So I had to restart it a couple of times, but I'm back now.
All right, cool, cool. Big up yourself. All right, so I'm going to integrate now with respect to x. No, let me rewrite first. That cancels that. So it's going to be xy squared plus 4xy minus y squared over 2 plus c dx. I'm differentiating with respect to x. Integrating with respect to x. Yeah, integrating with respect to x. Thank you, Papa. So now, integrating with respect to x. There's a question I'm going to ask afterwards. Integrating with respect to x is going to be x squared, y squared over 2. Integrating with respect to x. This becomes 4x squared y over 2. Oh, sorry, I never checked this. I'm integrating with respect to x. I'm going to differentiate this with respect to x. When I differentiate this with respect to x, I'm going to get 2xy squared over 2. The 2's cancel, so I'm just going to get xy squared. See here? Xy squared. When I differentiate this with respect to x, 2 times 4 is 8xy over 2. So that's 4xy. See there? 4xy. The one you know. Can call that the same thing as a half y squared. Talk truth. Yes or no?
Yes, sir.
Mhm. So minus a half, add 1 to the power divided by the new power times y to the third over 3. You see that? I added 1 to the power and I keep it a half as a constant. Adding 1 to the power and divide by the new power. So you're going to become
So is it the same thing as y cube over 6?
very good. That's what you got?
Oh, no, sir, no, sir.
But it would be. And then this is going to become plus cx. I finish right here?
No,
What I need to do?
put a constant again. See.
Very good. Plus c. So this now becomes x squared y squared over 2 plus 2x squared y minus y cubed over 6 plus cx plus c. That's finished.
Back the next one, I say.
I can. Are we okay with this also? Yes,
Could I copy this first, please?
I can send it off to you, as I normally do.
Okay.
I can send it off, man. Because I need to, you weren't here when we did this Lagrange. So I need to send it off immediately from the class. So we're doing a second example. And I'm making them up as I go along. Say x cubed minus xy plus y squared dx dy. Always look to see which one comes in the middle. Or I'm going to integrate with respect to what variable first.
X.
Big up yourself. I hear 5 minutes. After 5 minutes, then I'm going to come in. Yeah, because after 5 minutes, it's going to be 7 minutes for me to work it through with you. All right, never mind. We can fast. obviously.
Right, so we get another answer. So answer look like it.
All right, so let me work with X1 now with you, and then I'll give you another minute to work the y part in. I'm differentiating with respect to X. So this is going to become 3. I keep saying differentiating. I'm integrating here.
X to the fourth.
So it's going to be X to the 4th. Sorry, I need to write back. This is going to be X to the 4th over 4. Does that make sense?
Yes, sir.
Yes, sir.
Good. And if I differentiate this, I'm going to get 4x cubed over 4 with the 4 cancels. I'm going to have my x cubed. Minus, I'm integrating this with respect to x. So this is minus x squared over 2. Sorry, I had a blank thing a while ago. X squared minus 2 over 2. That's correct?
Yes, sir.
Plus, watch this. xy squared. You see that?
Definitely.
Good. Plus c dy. Aston, you see that?
Yes, sir.
Sir,
Come on.
how you verified if that x to the fourth over 4 is the same thing as x to the cube? Yeah, calculate a while ago, sir.
Because I'm integrating with respect to x.
Yeah.
When I differentiate that term now with respect to x, I'm going to get 4x cubed over 4, and the 4 is cancelled, so I'm just going to have x cubed.
Oh, yeah.
Yeah. So I did say I was going to show you a trick up here, so when I finish this one, but I never remember. So I will show you the trick thereafter when I finish this one. So now this is the differential of the integral of this. Now I'm going to integrate it with respect to y. What do I write here? So I'm integrating with respect to y. What is this when I integrate with respect to y? What do you think I'm going to get?
X to the fourth y over 4.
Very good. Minus x squared y squared over 2 times 2, don't?
Yes,
Yes, sir.
Good. Plus x y to the third over 3 plus cy plus c. And then this is going to rearrange. We're just going to x to the 4th y over 4 minus x squared y squared over 4 plus xy cubed over 3 plus cy plus c. And that's my answer. Tell me if you agree with me.
Agree.
Agree, sir.
Yeah, man. Thanks,
Agree.
Sam. Okay, great. Asamil, I don't hear that agree from you. Asamil gone. All right. Let me show you a trick as we are at the top of the hour.
Sir, me not gone, but me no know what happened to my mouse, and my mind is a bit distracted.
All right. You need to come back though. All right, let me try highlighting with a baby blue, a light blue. Watch me. You notice when I'm integrating, I'm integrating with respect to y. You notice when I'm integrating with respect to y, and I have my xy there, I don't need to add I'm integrating with respect to y. But y is here, I don't need to add a y there. When I'm integrating this term with respect to y, because there's no y there, I have to add a y here. You see it?
Yeah.
When I'm integrating this with respect to y, because I have a y there is no need for me to add an x here. The first term I'm integrating with respect to y, I already have a y, so there is no need for me to add a y. Watch me here, so. I'm integrating with respect to x. There is some x right here. I don't need to add an x here. there is some x here. I can just go ahead and integrate. I don't need to add an x, but watch this. But this is not correct. This is not correct, you know. Hold on. Am I not integrating with respect to x here? Why I integrated the y a while ago?
Hold on, no man, sir. Simplify it.
No. I had, then suppose me never look over this something, but when I go with wrong information. No man. But I had y squared over 2, and I simplified it to be a half y squared. But what I did right here was to integrate this with respect to y. You know, so I say y cubed over 3, right there, so true or false?
So then you would need to say x cubed instead of y cubed. Is that what you say?
No, I need to include an x, but
You see it, sir.
you see it,
Instead of
right?
xy cubed.
No, it would be xy squared. And it's a good thing, you know, when I was doing the question, I said, I need to tell you something. Did you hear me at first to say that I will show you something?
Yes, sir. Yes, sir.
Yeah.
Right. And it's and I'm so happy I remember in the second question. No man, something right here, someone. Let me keep the incorrect stuff and just write the correct stuff in red over it. So you can see the mistakes, so you don't make the mistake again, or don't follow me to make the mistake. So I'm gonna highlight this to be incorrect.
Oh.
That is incorrect. I am integrating this with respect to x. See it here, so with respect to x. So it has to be x y squared over 2. I have to add an x to it. And it follows everything that I'm doing here. I'm integrating, and it's when I reach here, so I recognize, if there is no x, in the stuff, when I integrate, I'm going to get an x, don't it?
Definitely.
Yeah, man. So it's supposed to be xy squared over 2. It's supposed to be xy squared over 2. So this is supposed to be xy squared over 2. And if you don't believe me, when I differentiating this with respect to x, the differential of x is 1. So all I'm going to be left with is y squared over 2. See it up here, so? Y squared over 2, right here, so? Y squared over 2. You see that?
Yeah.
Yeah, man. So that was an error right there. Did I fix it here? So, okay, good. So thank you, Lord. I'll leave in the incorrect stuff there so you can see what it is that we did. You have to be careful whenever you're integrating, just to make sure that, I mean, it's a simple error, yes, but of course, I will penalize you. Ensure that what you're integrating with is what you're using. All right? You have to integrate with the correct variable. And then the final point I want to bring across here is pretty much the same thing, but I just want to show you what is really happening here. I am integrating with respect to x. You notice I didn't add a y here. Chevoy asked a question, which is why I remember that I say I need to talk to you about something. Chevoy asked a question, sir, or you know, say this x to the 4th over 4 is the same thing as up here. And I just differentiate it. You have 4x cubed over 4. The 4's cancel, so you just left with x cubed. Isn't that what we start off with?
Yeah.
If I were integrating this with respect to y and there is no y, I will now need to put on the y there. You see what I'm saying? There is no, if I was integrating this with respect to y, there is no y here, so I'd have to go and add a y to it. So that's the point I'm making. If when you're integrating a term and with respect to x, and you only have y in it, you have to go add a x. If you're integrating with respect to y, I don't have a y in there, you have to go add a y. That's the point I'm making. So when we integrated, so let me just check that, that's correct. When we integrating xy now, with respect to x, it's not a problem because we just add the square divided by 2 and put back the y. The y we can hold as constant, right? When we're integrating this now with respect to what to x, we don't have no x here. Well, actually we do. We have x to the 0. You see that? And then when we add 1 to the power divided by the new power, then we're going to get x to the 1st divided by 1, which is the same thing as just xy squared. Talk truth.
Good.
Yeah, man. Yeah, man. And then now we finish the first integration. So we can call it proceed, your constant of integration. Right? Your constant of integration. And then now we'll go through again now to do the integration with respect to y. There is no y here. So we have to introduce a y. So this is simply x to the fourth y over 4. We have to introduce a y because we integrate with respect to y and there is no y. We integrate with respect to y here. So we don't have to add nothing, we just integrate. So this is minus x squared y squared over 2 times 2. Because we still have to divide by the new power. And we integrating with respect to y, we just go and say xy cubed over 3 right here. So are we integrating this constant with respect to y? We don't know what the constant is. Had it been 5, it would have been 5y. 10, 10y. A million y. We'll call it cy. We'll call it cy. Oh, crap. We'll call it cy. Right? And of course, every time we finish the integration, we have to put a constant of integration. Point I'm making is, when Chevy says to me, sir, I got cx plus c, I did say good right here. Is it true or false?
Yeah, there's a
True,
truth
sir.
to that.
Yeah, man, because I knew it's supposed to be like that. And then I say, you know, whatever this answer was, I say something missing right here. So, Shamoy, Mari, something missing right here. So, because I know I'm supposed to, and if you don't have the cx plus c, you're going to lose the mark. Very important. And then all we did was just, all I did, I write, but this is the same line as this, except that I just put the 2 times ways 4. And that's it. There is no biggie about it. Come Friday, God's willing. I did say to you that I have one more topic. It's not a difficult topic, really and truly. I can use a half an hour if you were to ask me, because Lord, I can use a half an hour to teach that topic on Friday. And I put it this way. It's like how I was saying to myself, I did a bad job on Lagrange multiplier because every question I give you, sir, boy, now work out. And now I give you enough questions that you guys are working the questions to its entirety, and getting the questions correctly. So I'm going to spend more than a little than half an hour on this last topic because I tell you, real talk, it not bad. But what I want to also do, I know in the last part, I have been spending quite a bit of time on double integration and Lagrange multiplier. And them first topic they will go through one long time. I don't know if you remember them, but yours is going to be the responsibility to come next week while you're revising, to revise through the stuff. Point I'm making, guys, is I don't know how I was able to do it. I was a little nervous with the block scheduling, but and where I became nervous, it's not that I wouldn't be able to teach and mark papers and so forth because they'd already conditioned my mind. So, yo, the weekend here, I gotta mark up the papers in so the students can get them grades. I was a little concerned mostly for whether or not I'd be able to complete the syllabus. And to be honest with you, I think I even complete the syllabus better than if I were doing the course without the block scheduling arrangement. I have one last question to ask you. One last question. Because I'm doing a research and I'm going to need you to get some information from you. And this question I'm asking you is not to boost my confidence, is to tell me the honest truth, the only truth that Jesus loves, because it will help me as an individual to do better. How do you rate the online class that and I don't want to hear no good or bad. I don't want to hear that. My question is, how do you rate my online teaching and your subsequent learning? I want you to rate it by telling me the aspect that you like and the aspect that I'm supposed to improve on. You can just give me one no, you can think about it, and then come Friday, you can tell me the rest. I started with you, Shamari.
Really appreciate it, sir. You really got like you explain the whole topic from head to toe, A to Z, so that we can really get it. So I like how you do that. I like how you ask questions so that we can participate and to see if we're following along. And honestly, I not see, we can't think about how you can improve anything, but we will go and think about it.
All right, then, cool. Appreciate it, Papa. Astabil, you're next. Don't you gonna rub me out now. Go on here, my sister.
I'd never do that.
Go on, honey. What's up?
I concur what Shamari says. However, sometimes for me,
Mhm,
and I guess I'm speaking on behalf of myself and Anthony, knowing we're the only female here.
mhm,
Oftentimes it's a speed for me. So
mhm,
because you go so fast sometimes,
mhm,
I don't really get the chance to soak in as much in class. So I have
mhm,
to depend on the recording to
mhm,
go through and pause. So if I don't go through the recording, I have an issue when I come to class. And I know that.
mhm,
Detailed, very good. I wouldn't recommend block scheduling though to
mhm,
anyone,
mhm,
because if your mind is not there, you won't get through it, because it
mhm,
takes a lot, especially knowing that you have other courses that may be demanding.
mhm. I appreciate that. Um, to be honest with you, if I were to be, and this is our secret, I know it's the digital footprint can be retracted, but I'm going to say it nonetheless. Of all the courses that I'm doing this semester, and incidentally, I ended up picking up 2 additional courses for for this semester. Um, these Calculus 1, Calculus 2 took the most out of me because I know how demanding it was. You notice I could send a little one question here, a little one question there, and say, all right, I had a challenge logging on today, but I had my question ready. So I could have just copy it and just send it over WhatsApp and say, go and work until I sort out this something here and thing and thing. So in terms of preparation, I'm not gonna lie to you, it required, as you come to the end of it, I can sit back and kind of breathe, but I'm not lie to you, there are days, I mean, I always come prepared to class, but there are days when I had to sit up to make sure that my preparation was on par. I had to do what I had to do in order to come to class. I couldn't come to class one day without being prepared for class, because if I did that, I would have been in trouble today, to the point where I was sick. I had a flu 3 times for this semester, for this block scheduling, the half of the semester. And I couldn't give up the class because I know right about no, I would be in problems. I said, guys, I have 3 topics left, and I know I didn't want to put you guys straight. So even when the body was saying, yo, take time. And I believe why I came down with the flu at that time is because of the pressure that I was under. So I know estimating that it is rough. In the middle of the semester, I can confess, in the middle of the semester, I said, never again. But being at the tail end of it now, looking back, I'm saying, it really not so bad. And if you are like me, that, it's like all these stuff that I write, at some point in time when there's a downtime, I'm going to type them up so that I can add value to my document, so that I can send you the typed documents instead of the handwriting. I only write now because these questions are fresh questions. The questions that you see me project being typed are questions that I would have done prior, or I would have had enough time to do the question and then type it up so I can have it for you. But I appreciate that. Thanks for that. Simon, what do you say?
Sir, I don't really have nothing much to say, but I appreciate that you sent the notes as well for the things that we do in class, so we can go back over.
Mm-hmm. All right.
Yeah, that's all
Gotcha.
I have to say for today.
All right. Bless up, Papa. Chevy,
Yes, sir.
what do you have to say?
Well, sir. Sir, me never know it. Possibly not, sir. You would be calculus 1 and calculus 2 in one semester, you know, sir.
Yeah,
That normal enough, sir. So
trust me, trust me, trust me.
Not that impossible, sir, but they're moving around.
Yeah, man, trust me, man, trust me. And you know what I like about it is that there are students in here that we're not talking about getting the C's. Um, I'm talking about, B students, high B's. And that's why I've spoken to one student already and send up my threat. And I'm going to execute my threat and I'm going to send up the threat to everybody now. You all know your grade that you receive for Calculus 1. I am proud of you guys. The grades for the calculus classes for me from this batch. The very first batch that I taught, I got a couple of A's. The second batch, I got a couple of A's. But in the subsequent batches, they were passing, but they were passing. But I'm seeing an improvement in this current batch. And I'm going to challenge you. I need to see an A or 2 or 3 or 4 or 8 for this calculus too. It is possible. Me now ask you, I am telling you, it is when you're going to the exam, you're going to see that, oh, I can do all the questions. I should be able to answer all the questions because I would have completed the syllabus when I move into Friday's class, right? So it's just for you to go into the exam and select your best 2 combination. Look at your questions, and if there is a stationary point, of course, I'm going to tell you to run for the stationary point because it's all of 30 marks of that. So make sure, say, you have that part. And then for your second question, look at the arrangement of the questions. So if you get question part A, part B, part C, but you recognize there's only part A you maximize, you look at the other question. If you look at another question, this is a boy, question 3 now commit A, B, and C, but there's only A and B, me can do C. You look on question 4. And if question 4 come, you can do A, B, and C. You run for the question where you can do all of them so that you can maximize those points, right? I'm hoping to finish marking the SBAs, not the SBAs, the mid-semester. So at least you can have an idea what percentage you're going into the exam. The final thing I'll say is you guys now need to complete your edit for self. The ball now is in your court. I have done my part. The ball is in your court. I'm still depending upon you guys to make me feel or continue to feel proud of what it is that you're doing. Big up on yourself. We'll talk on Friday.
All right.
Nice
Yeah,
one, Jimmy.
no problem. Yes, ma'am.